Hello everyone. I will now walk you through question 8 to 12 from the problem set 12.1 formative. As you guys can read here, the following questions are about the Bohr model of the hydrogen atom. Bohr here refers to the famous Danish scientist who studied atomic physics. Let us begin by addressing question 8. Question 8 reads, using Coulomb's law for a proton and electron, the fact that this force is centripetal in nature, show that mv squared equals ke squared over r for an electron with orbital radius r. As for any question in physics, we must first begin by identifying what has been given by the question. First of all, Coulomb's law. Coulomb's law refers to the electric field force equation given here. This can be found in section 10.2 of the data booklet. Next, the question refers to a proton and electron, which can be grouped into a hydrogen atom. Next, the question refers to the centripetal force, which is described by the given equation. The equation here can be found in section 6.1 of the data booklet. Finally, the question asks us to prove that the relationship up here can be represented by the following equation: mv squared equals ke squared over r. I've compiled all the given values into this square here. As you guys can see, the charge of an electron is equal to the charge of an electron, and the charge of a proton is equal to the opposite of a charge of an electron. Therefore, it is negative E. First of all, we can substitute this information into the electric field force equation, as you guys can see here. Next, we know that from the question that the Coulomb's force and the centripetal force should be equal, as they are assumed to be the same. Therefore, we can set these two equations to be equal to each other. Note that the equation for the Coulomb force already has the charges for the electron and proton substituted in. Then we can arrive at the equation given by the question. You can do this by multiplying both sides by r to cancel r on this side and the square part on this side. And the e can be combined into e squared. That's it for question number 8. We also later learned that the assumption that the forces within the atom is centripetal is wrong, because electrons actually do not travel in circular paths. Therefore, the centripetal force equation cannot be applied. Moving on to the next question. Question 9. Using result from 8 and the definition of mechanical energy, E equals energy kinetic plus energy potential, show that the total mechanical energy of a hydrogen atom is given by this equation here. There's a hint given here, which is the equation for the potential energy in an atom. As you can see, the result from question 8 has been copied over, and the definition of mechanical energy has also been given by the problem. Next, we can also add more detail to this equation that's been given by by using the equation for kinetic energy, 1/2 mv squared, and the given equation for potential energy, negative ke squared over r. Now we can begin solving the question. Now let us begin question number 9. Using the result from 8 and the definition of mechanical energy, E equals kinetic energy plus potential energy, show that the total mechanical energy of a hydrogen atom is given by the following equation. The equation for potential energy has also been given. Here first, now we will identify the given values from this question. The result from number 8 has been copied here, and the definition of mechanical energy is also given by the problem. In addition, the question asks us to prove that the mechanical energy of a hydrogen atom is given by the following equation. To add more details to the definition of mechanical energy, the equation for kinetic energy is 1/2 mv squared, which can be found in the data booklet, section 2.3. The equation for the potential energy is given by the problem through the hint. Now that we know all the given values, we can begin solving the question. Using the values given, we can substitute them in to the definition of mechanical energy. After substituting the equation for kinetic energy here given by the data booklet and the equation for potential energy given by the problem into the definition of mechanical energy, you should get the following equation, 1/2 mv squared plus negative ke squared over r. From here, you can substitute in the result from number 8 for the mv squared part and end up with the following equation. When we simplify this, you should get the equation given by the question here. That's it for this question. Let's move on to the next. The next question reads, write the relationship between angular momentum L and momentum P equals mv for an electron orbiting a hydrogen nucleus at a radius of r. For this question, we must first identify the given values. First of all, angular momentum L. From the data booklet, we can section 12.1, we can see that the angular momentum can be described by the following equation. And there is also another equation given by the question for momentum. However, this can also be found in data booklet section 2.4. That would be it for the given information for this question. We can now begin solving for the answer. So from if we substitute in the equation for momentum into the equation for angular momentum, we get L equals PR. And from this equation here, we can deduce that L over P is equal to R. This question is fairly simple, hence the question asks to write the relationship. As it is so easy, it is recommended that you memorize the following relationship so you don't have to take up time to deduce the following information. Question 11. Write the assumption Bohr made for angular momentum in formulaic form. This question is fairly simple as it asks you to write down. Therefore, you don't have to deduce anything. From the data booklet, you can see that the angular momentum can be described by the following equation. This is the assumption Bohr made. To add on a little bit detail for this equation, he assumed that the angular momentum L equals mv r of the electron was quantized, meaning that it can only have several discrete values. Can't be continuous. The n here is the quantum number or the energy level, which is the quantized part of this equation. It can only be an integer. There isn't energy level 1.2, 1.3, and so on. You get the idea. On to the next question, question 12. Using 8 and your results from 10 and 11, show that r equals n squared h squared over 4 pi squared k squared m. Let's find out the given values here. From question 8, we know of this equation. From 10, this is the equation we reached, and 11, here's the equation. And the question asks us to prove that this relationship using the equations given below. Here are the given equations in more simple view. Although there are 3 equations, these two are sort of the same thing, but in different forms, so we only have to consider this one and this one. To begin, we take out mvr equals nh over 2 pi. Then we have to raise both sides to the power of 2, as you can see in the equation given, n and h are squared. Then from here we divide both sides by mr squared to result in the following equation. mv squared equals n squared h squared over 4 pi squared mr squared. Then from here, as you can see that we can substitute in k squared over r for mv squared to end up with this equation right here. And if we divide both sides by k squared, we end up with the given equation from the question. This is how Bohr did it. Thank you guys for watching. I hope you guys learned a thing or two.